Okay, welcome back. Today in this video we're going to again talk about some definitions regarding sets. And so this is going to be important for later in discussion. What do I want to use? So let's start with universal set. So these are other terminology and things that you're going to want to know, because when I use them you'll know what I'm talking about. The universal set, it's the set of all objects under discussion. So if I say I want the set of if I want the, okay, here we go. I want the set of all politicians who tell the truth. Well, what's the universal set that I'm talking about? Well, I'm talking about politicians, right? Or people. Right? So a universal set of objects that are under discussion could be people, right? Politicians could be within that group of people, or my universal set could be just politicians. I could be just talking about all politicians. It just depends on the context. But that's the idea of a universal set. A universal set is the set of all objects that are under discussion. Okay. Now, the null or empty set, as you might get from the word empty, is a set that is the set that has no elements in it. Okay? It has nothing in it. Which you might think is weird, but it does come up where we have to use the empty set. Okay? Not only in mathematics, but also in logic. Okay? So, and there is a direct connection between mathematics and logic as well. If you ever take a logic class, it'd be good for you. I think a lot of the mathematicians from history, famous mathematicians, were also philosophers and logicians. Okay, so now, subset. Now, the subset is given by the symbol with a sideways U with a line underneath it. Okay? So, how do I define a subset? Well, in the generic sense, a subset is like a, if I was talking about it's a set of objects that is contained within another set of objects. Okay, that would be a subset of another set. Okay, so a set within a set would be considered a subset. Okay, so we consider. So we would write it like this: A is contained in B. So A is a subset of B if all the elements of A are also in B. That's the definition of a subset. If all the elements of one set are contained inside another set, then that set is a subset of the other set. Okay? So in this case, we're saying that A is a subset of B. Now, what's the difference between saying subset and a proper subset? Well, this bar here, you could say is like an equal sign. You know how we have symbols for inequalities, right? So we have greater than, or less than, rather, less than or less than or equal to, right? So this underscore here represents equals. Same thing here. What this is saying is A is a subset of B, but also allows for the possibility that A is equal to B, which means A is the same as B. Okay? That all the elements of A are also all of the elements in B. Okay? If I don't have the underscore, then I'm saying it's a proper subset, which means that all of the elements in A, so if I say this, right? So if I say A contained in B, if I write it like that, then what I'm saying is that all the elements of A are contained in B, but not all the elements in B are contained in A. So they're not the same, they're not equal. Okay? So, What do I mean by that? Well, let me use a Venn diagram to show you what I mean. So a Venn diagram is a visual way to see the relationship between sets. Okay? And it's very useful. So in this case here, okay. If I say A is a subset of B, this is the way we would depict a proper subset. So the inner circle represents the set of A, and the outer circle represents a set of all objects contained in B. So this would be a proper subset because you can see that everything in A is contained inside B, but A is not equal to B, which means there are objects out here that are inside B but outside A. And so this would be the way we would to show visually, using a Venn diagram, that A is a proper subset of B, because we're not allowing for it to be equal. So if we're allowing A to possibly be equal to B, then that's a subset. Okay? If we're not, then it's a proper subset. Okay? And we would depict it this way. Another Venn diagrams, we could see, hey, Venn diagrams are great for showing relationships between two sets. Right? So there's another Venn diagram. Okay? So there's ways of using Venn diagrams to help us understand the relationship between sets. And not just two sets, but we could expand this to 3 or more sets. Okay? Anything else I want you to say? Oh. Okay, the null set. Let's go back to the null set. Okay, so how do we, universal set. Let's go back to the universal set. So the universal set, we denote the universal set using U, capital U. Okay, so that's how we denote the universal set, is capital U. The empty set, there's two symbols that we use for the empty set. We can either use this symbol here, which is basically an O or a 0 with a slash through it. Okay, or we could use the set braces and just not have anything between them. Okay, so we can use this symbol or this symbol, but do not use that symbol to represent the null set, because it doesn't. Okay, that represents the set that contains the symbol of the null set. Okay, so this we don't use for the null set. So either this symbol or this symbol to represent the null set. And I think that's it. That's all I want to do. Okay, have a great day, and we'll continue next time.